Hi, everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your virtual star party for November 4th, 2012. So tonight we've got, I believe, 4 astronomers joining us live, as well as some color commentary. So first, from left to right, as I see them, I see Bill McLaughlin, who's in Oregon.
Howdy.
We've got Gary Gonella down in Los Angeles.
Evening.
We got Roy Salisbury operating his virtual telescope from Las Vegas, and we got Stuart Forman in the on a hill near his house in the San Francisco area.
Hello.
And then joining me for a color commentary, we got Szabo, Dr. Szabo, also from the Los Angeles area.
Good evening.
All right, cool. So what's happening in the sky tonight? How's the weather been for everybody?
Pretty nice out here.
Yeah?
Great.
Yeah, it's like perfectly clear. It's as usual. It's completely stormy here. So.
Yeah, the moon won't be up for quite a while, so we'll have dark skies and no moon complaints tonight. So that'll be nice.
Yeah, that'll be good. I don't know if people remember last week we had a bunch of cases where the moon was just, the light from the moon was completely sort of outshining the object, and you could even see which way the moon was. You could tell which direction the moon was in just by the amount of noise that was coming into the imagery. So, well, good. Well, why don't we get started then? So we've already got some images up from some of the astronomers here. So Gary, what have you got here? Have we seen this yet?
This is, I don't think we have. This is the Cocoon Nebula, and I'll zoom in a little bit here. It is IC 5146. I just ran across it today when I was looking for things to come up with.
I think we did this last year. Like, I remember the Cocoon Nebula, but I think we haven't seen this for like almost a year now.
It sounds
very possible. It's fairly low.
What kind of object is it?
That?
So, Gary, we're shooting hydrogen alpha? Or?
Yes. Yeah.
Okay.
Still hydrogen alpha.
So yeah, anytime we're looking at hydrogen and seeing it glow like this is an emission nebula. Not sure about the particulars of this one. If we've got maybe a Wolf Ray in the middle, or if it's again just a very massive and extremely hot star that's filling the region with ultraviolet radiation, knocking electrons off of that hydrogen, and then as it recombines, you get this glow. So if we were putting this through color filters, it would have that distinctly red glow. Off to the, looks like the upper left in this image, you can see that things are a little bit more obscured. So looks like there's a pretty good dark nebula kind of in the upper left corner of the cocoon here, and you can see that even extending into the top regions of the cocoon. It just looks like the density of stars around it. Oh, there's good. If we zoom out a little
back
bit.
out, you can see it here and here.
Yeah, the amount of starlight really drops off. So are we looking in Cassiopeia here? Or
oh shoot, I didn't write it down.
Okay. It was the Cocoon Nebula, though, right?
Yeah. It's the cocoon.
Yeah, we don't have Scott here tonight, so I am going to be the stellarium, the human stellarium, if I can.
Let me see. 46.
Let's see. So, just the depth, the density of stars in the background makes me think it's somewhere along the Milky Way. So I'm thinking maybe Cassiopeia or Perseus?
It is along the Milky Way, and it's going to be between Cygnus...
That's crazy that you can do that. Well, looking at the density of the stars here, I'm going to take a guess that it's in the Perseus region. That's madness.
A little bit of process of elimination. I know I haven't run across this in the Summer Triangle region, and
it's in the edge of Cygnus.
Edge of Cygnus. Okay.
Mm-hmm.
Okay. So kind of Cygnus-Cepheus border, I guess then.
Yeah, or actually, it's right against Lacerta, Lacerta.
Okay. Yep. The lizard that will not show up for most of our viewers because it is so faint. One of those constellations that only has with the magnitude scale working backwards, so bigger numbers mean fainter. The brightest star in it, I think, is 4th magnitude, meaning you've got to be pretty far out from city lights to even see one star in that constellation.
Okay.
All right. Apparently my computer is not going to behave tonight, so never mind. All right, well, let's move on, because we've got some other objects happening now. So we're going to move to Roy's view, and I guessed it, that is M33, right? The
Yes.
Galaxy in Triangularum.
Or I guess just Triangulum, right?
Triangulum.
Yep. But again, this is one of our neighbors, kind of our little neighbor. Andromeda, the Andromeda Galaxy would be our big neighbor, and the other spiral galaxy that's nearby. And nearby here is only 3 million light years, but really there's only 3 kind of major galaxies in our little region of the universe here: the Milky Way, Andromeda, and this one, the Triangulum Galaxy. So, with this exposure, you can see some kind of loosely organized spiral arms, rather broad spiral arms stretching off from the central structure there. Patches where it gets brighter, where there would be a pretty intense star cluster in that galaxy. But from our point of view here, you can really kind of see the spiral structure. And there's a nice, not picking up exactly where it is here, I'm sure it's in the photograph, but there's that very nice, huge emission nebula that's in the galaxy that kind of shows up on its own. So,
I'm seeing a lot of stars in this picture, Thad. That's telling me that it's probably somewhere in the Milky Way.
Oh, the density's not nearly that good. Yeah,
it's pretty close. It's just off the Milky Way, though, isn't it?
It's where is it?
I don't think the galaxy would be in the Milky Way, Fraser.
Yeah, you wouldn't be able to see a darn thing.
That's true, but no, it's just off to the right of Perseus, right? It's just below Andromeda. So
right.
The galaxy is on Orion's belt. Everybody knows that.
but the other thing that's cool though is you can see that satellite going through.
Yeah, over to the left, that little line. I don't know if that's going to be visible for our viewers quite as well, but yeah, with a sharp enough view here, you can see that line over on the left side of the picture. That's something much, much closer than 3 million light years away.
Now, this is one of those objects you can see with the unaided eye if you have really dark skies, right?
If you're in incredibly dark skies. The only place I've ever been able to pick it up with naked eye is Death Valley.
And if you've got really good vision.
Yeah. I mean, you need to know where you're looking in the sky, and you really need no humidity and no light pollution. So otherwise, it's a great binoculars kind of object. I mean, it's going to show up a little bit faintly in binoculars under most conditions, but you can really make out something that looks actually a lot like what Roy is showing here. Is kind of the view you get in binoculars, minus the satellite.
So just to let people know, we are actually watching the comments. So if you're commenting on the event page, we'll see that. You can also comment on the Google Plus page in the stream. You can comment over on YouTube if you want. You can use on Twitter with the hashtag StarParty, and we'll see that as well. And so we'll take requests. We'll answer questions about space and astronomy. If you have some observing questions about how to use your telescope, what telescope to get, what telescope everyone's using, how to do imaging, all that. We're glad to answer them. And Thad teaches this as his day job, so we can absolutely get those questions answered.
Yes, absolutely.
Remember, my promise is to always take any question, and then I get to make it a lot harder, and then pass it along. So, well, let's move on. So, Stuart's got an image up, and I can see. Oh, that looks like the double cluster in Perseus.
This is the double cluster in Perseus, exactly.
Oh, that looks beautiful.
Thank you.
Yeah.
Yep. So, if you are somewhere dark enough to see the Milky Way, this is a bright patch along its length. Kind of between the W that's Cassiopeia, and then there's kind of an arc of stars that mark Perseus. At this time of year, would be below Cassiopeia. And about halfway in between the two, you'd see this slightly brighter patch, and this is the double cluster. So it's 2 star clusters, roughly 6,000 and 7,000 light years away. It might be 7,000 and 8,000. Anyway, they're both in the same direction of the sky. Clusters that would have formed each one from a separate cloud of gas and dust, and basically, having this massive amount of star formation all at one time, and they're still hanging around each other gravitationally, so that when you look in that direction, you just get this myriad of stars, in a binocular view or a wide telescope view like we have through the camera here that Stuart's showing us. So.
Yeah, and again, another object you can see with the unaided eye, barely, like it's a fuzzy bit in the sky, and with binoculars, it just really pops.
Right, but this one is bright enough that it's if you're somewhere dark enough, it definitely does jump out at you. Hey, what's that little bright cloud over there? So, yeah, this is one that it's really strange that Messier missed it in his list.
Oh yeah. Now last week, Stuart, you were going to play around with your white balance. Did you? Is this the new technique?
Yeah. How does it look?
It's good. It looks still a little noisy. I'm just wondering, is it still a little bit light there, or?
Yeah, it's light. Yeah, it's still I still have twilight.
But it doesn't have that characteristic blue hue that it had last week. So I think, I think it looks great.
Great.
Yeah. And why don't we move on to what Bill's got? This is great. Also the double cluster, Bill. That's great. Another view of it.
Oh yeah, and colors coming through a good bit more in this one. So, are you shooting? Is this a color CCD camera or DSLR that you're shooting with, Bill?
I don't know. Maybe
he's muted.
Bill.
He's
Yeah.
muted. So,
I think he's doing a quick image in with three filters and then stacking them.
Okay.
Yeah.
So, I mean, one thing that really pops out on this image is, the stars that make up the cluster are fairly hot, that they're showing up as whitish or bluish. And when you're thinking about colors with stars, you don't want to think about like how your water faucets are labeled in your house, where the red is hot and the blue is cold. You want to think more of like a flame. And so, if you have a red flame, that's cooler than a blue flame. So one other thing we kind of see is poking around in this image a little bit is these red stars that pop out that are not necessarily part of the cluster, but other stars, most likely in the foreground, that have already gone through their lives and are now swelling up as red giant stars.
So those are all red giants, or are they, would any of them be red dwarfs, or are they all red giants?
It's very unlikely that they'd be red dwarfs, just because, I mean, even the closest star to us, Proxima Centauri, as a red dwarf, is not visible to the naked eye. So as soon as you start heading out, even tens of light years, red dwarfs start to become so faint as to be practically invisible. So it's most likely that if anything is in this field of view that's showing up as red, it's most likely a red giant.
Oh, that's fantastic. And I love the color view. I mean, it's really with the color pictures, these clusters can really sort of show up. You can really see the different stars and the different colors, and yeah, it's great. All right, why don't we move on? So one question here, James Haney asked. I'm sure it's been asked, but what is stacking? So I guess we use stacking quite back and forth here quite a bit. So when we talk about stacking, what are we talking about then?
So the idea is any one image here is taken for maybe 30 seconds up to 2 minutes, and any noise in the picture stays in a single image. You essentially have an electronic signal, and if, say, part of the detector has been hit by a cosmic ray, or there's thermal fluctuations in it, and it can introduce noise into the signal. So when we stack, the thing that comes from what we're observing itself, anything that's a pure signal from the light from the stars or the nebula, will be increased, and the noise will be decreased. So the whole point of stacking is to bring out the contrast and reduce the noise in whatever it is that we're trying to see specifically.
And along the same lines, from a technical point of view, we also typically do what's called dithering, which means that each image in the stack is going to be offset by a pixel or two or a pixel and a fraction. So that basically puts the defects on the chip in a different place in each image, which allows you to use data rejection algorithms to remove the noise that might be caused by your detector defects or detector noise.
And somebody mentioned, Andrew Rapine said, we've seen several Taurid meteors tonight. Have you guys caught any in tonight's pictures? not tonight, but happens. It does happen occasionally, especially if you're doing really long stacking, long exposures. I'm sure you end up with a lot of meteors, especially satellites.
I want to check on that because I have a meteor shower calendar app on my phone, and so it usually bugs me quite frequently if we're near the peak of a meteor shower, and it hasn't been bothering me recently. So I'm kind of doubting we're near
a meteor shower.
Near a peak. Yeah, these could just be random, and that happens. If you watch the sky consistently for minutes on end, you will see a couple of meteors if you're somewhere dark enough. There's a background rate that's typically 5 to 10 an hour. A shower is going to be, you're going to see meteors that look like they converge from or diverge from a point in the sky. So you would see meteors kind of all coming out from basically the same position in the sky, and that's when you would know that they're part of a shower. So let's see, we have the southern Taurids peaked on October 10th, so that was a while ago. We've got northern Taurids. Okay, they peaked November 12th, and so that shower would be ongoing. I'm sure I'm going to get lots and lots of reminders about that this coming week then.
But like a week today, it should be a lot better.
Yeah. Let me see if I can get some details on this. I'll be out in the desert then. Let's see.
Be nice.
Yeah, so zenith hourly rate is about 5 an hour. So, it's not a very strong shower, but, showers are never just like, oh, it's this, 10-minute window or something like that. The beginning date when we start to enter this trail of debris that was left by a comet previously, that would have started on about the 20th of October, and we leave that trail of debris on about the 10th of December. So it peaks, roughly a week from today. So
the only like honest storm that I've ever seen was the Leonids that happened back in 2001, I think it was. It was just a crazy Leonid storm.
You mean you live in BC and you still saw that?
I did. It was crazy clear.
So that's the thing. These patches that are left behind by comets. Some of them are pretty good, like the Perseids and the Geminids on a regular basis. Perseids usually coming second week of August, Geminids coming second week of December. But the Leonids, they're regularly a decent shower, usually peaking around November 18th. But there's a really thick patch of stuff that was left behind by that particular comet. I'm trying to remember if it was Swift-Tuttle. But anyway, when we hit this thick patch, it's about once every 33 years. It's the only time that meteor counts ever go up above, maybe 200 an hour. It's the only shower that's ever produced anything like that. And in fact, if you go back into the 1800s, the western U.S., still being settled, still frontier land at that time, witnessed more than 100,000 meteors an hour. The sky looked like it was falling to them. There was just reports of, Armageddon is what it would have looked like to people witnessing it. That I thought it was amazing. 2002, I saw I can see 2 or 3 meteors in the sky at a time with the Leonids, and I thought that was cool. But just to imagine that much debris raining into Earth's atmosphere and lighting it up as it goes. You're talking a sky density of hundreds per second with that kind of storm.
I cannot imagine. That would be quite something.
So, but we're going to have to wait till 2033 before we're back into that thick region of it again here. So,
all right, let's hope we all live that long.
Yep.
All right, well, let's move on to this next object. Gary's got a beautiful, beautiful object tonight.
This is IC 1805 called the Heart Nebula. Now, when I look at it, this is in Cassiopeia. It looks to me that they're saying this looks like one chamber of the heart. This looks like the other chamber of the heart. So I can kind of see how they came up with the description for it.
Okay. And the bright bundle in the middle would be like the bundle of nerves that's the pacemaker, the natural pacemaker in the heart? I don't know. So, I don't have a medical degree.
I do.
Okay.
Sort of, kind of.
Sort of, kind of. Perfect. All right.
So.
You're a doctor too, just a different kind of doctor, like a proper medical doctor.
Someone who can actually help. So, But yeah, again, we're looking at dark nebulae in the regions that are showing up darker, and just a lot of hydrogen getting excited by. It looks like a pretty good young cluster in the middle there. It's really a lot of stars contributing to the light that's glowing here. So. That's typically what you see happening. You have a region of gas and dust. Some of it starts to collapse to form these large stars. Those large stars die as supernovae, and it kind of acts like a snowplow in front of the supernova, causing more stars to form in front of the shockwave of the supernova. So now you get more large stars, and they die, and they make more stars in their death, and so you can get a huge patch of really bright stars in one region of the sky to really light up a cluster and light up a nebula like this.
It's a really big object too. I didn't realize. How much of are you like zooming in quite a bit, Gary, or is that that your whole field of view?
No, that's my whole field of view, and I've got I'm probably covering about 60% of it. There's some more that goes off to the left and at the top, and also down here at the right.
Yeah, this is why Gary has his scope, because of this right here.
Yeah.
For things like this, yeah. So just to keep in mind, I mean, with Gary's scope, you could fit like 2 full moons top to bottom and 3 full moons right to left in that image. So that just shows you how big this object is in the sky. But we wouldn't see an object like this with our own eyeballs, right? Because it's just not without hydrogen alpha.
Right, not with our own eyes, and possibly not even with a telescope. There are some objects that just have such a low surface brightness, meaning that although when you can use a camera view and take in light for 30 seconds to 2 minutes at a time, then it's possible to be able to bring that into the image. But most of this gas, if you looked with a telescope, even from good dark skies, you probably wouldn't see a thing. Maybe you'd see this star cluster. I would guess that you would probably see this star cluster in the middle. But all these wonderful swirls and eddies and long filaments like that, that's something you would need a camera to pick up.
Wow, just phenomenal. Have you got another picture queued up, Gary?
Yeah, ready to go.
Yeah,
so do I.
Oh, do you? Okay, yeah.
Yeah.
Oh, okay, yeah. Stuart does have a new one. Okay. All right.
Yeah, there's. I just got today's Sky and Telescope, and there's a whole article on cool little star clusters that nobody's ever heard of before. And this one is called Trumpler 1. And it's just northeast of M103, which I'll do in a little bit. But it's got a tiny, that straight line of 4 stars is about 12th magnitude, and it's just kind of cool looking.
Yeah,
and that's kind of what star clusters are. They're just kind of cool looking.
This is.
Scott just checked in. He just posted a comment and said that, hey guys, I thought I'd drop in and say I'll be gone this show and most likely next show due to moving to a place that's more convenient for work and study. So yeah, he's going to be out of commission for the next couple of weeks. So we miss you, Scott. We'll see you back soon.
Good luck with the move.
Yeah.
Yeah, really.
So, I mean, that's one thing. I know a lot of times with teaching, you put something in the field of view that looks somewhat familiar, and we've got this line of stars here. I just know a lot of my students, if they were looking at this in the telescope, not realizing the size of the field of view, would say, "Oh, is that Orion's belt?" Now it's 4 stars there instead of 3, but it's that very linear arrangement. I think that's kind of the first thing that comes to mind.
Yeah, it's very, very small. I had to crop this quite heavily to get this, and so it's really quite tiny.
Oh, it's a great little cluster though. That's neat.
Yeah, I'm getting a few more here, so I'll next go to Gary and I'll get you some more.
Okay. Perfect. Oh wow, God, Gary, you're getting all these monster nebulae tonight. Look at that. There's like some kind of like these little spider creatures in the nebula. What is this?
This is called the Soul Nebula, and it's right next to the Heart Nebula.
Okay.
It's about 1 field of view of my camera away. So it's just below it, and here's a center area. I don't quite know why they call it. I'll move a little bit because there's more of it down here in the bottom. But there's a crescent right here that shows up. And I'll move a little bit and get the lower part.
But like, look at that strange. Like, I don't know if it's like a camera artifact, but there's like in the upper, or I guess on the right hand side of it, there's like this. Almost looks like a no, more to the left from that, Gary, and then down a bit. Yeah, it's almost like there's like some filaments or something. And then there's another thing down at the bottom there. I'm not sure what that is. Whether that's just the camera or.
I think that's real.
Yeah, I would think so too. I mean, when I first got into astrophotography, I think I still have one of my Pleiades shots posted that has this gorgeous like Lissajous figure in it, and I didn't realize that no, that's a camera effect. That's not actually in the field itself. So I mean, there's generally a little bit more symmetry to camera effects than that. That definitely does look real.
Yeah, this looks like a real artifact with some dark chambers in here.
Mm-hmm. Yeah, it's a nice zoom in there. Wow, it's just almost gives this kind of like seagull flying to the bottom of flying off the bottom of your screen kind of feel there with that region.
With a black rat in its mouth.
Yeah, there we go.
So
Darn it,
I
it stole something!
I found an image off Wikipedia here, so you can see sort of what it would look like if it was it was actually color and.
So Gary, what's the IC number for this again? Sorry.
That's the 1848, and it's in Cassiopeia.
Okay.
And I can't. Let me see if I can rotate mine. I didn't put flip in.
Yeah,
I'm still here. I'm just having a few technical problems.
Oh, no problem. Yeah, it looks like it's also like mirrored. Maybe it's flipped and then. But anyway,
it's mirrored.
Yeah.
So. Yeah,
I think on the left hand, I guess you all see it on the right hand side. Is that sort of? I don't know. It looks like a little creature or something. I'm not sure.
Yeah, if you look on the right side of yours, you see this little tendrils coming out.
Yeah.
So that's that. So I'm 90 degrees and then flipped from what you're seeing. Or no, you know what? Maybe not.
What a beautiful little object.
That might put it. That puts it about the same orientation, but it's smaller, but you can see the tendrils sticking up here.
Somebody was wondering if they could see NGC 7331.
Oh, yeah. That's well placed this time of year. So,
what is it?
It's a spiral galaxy, maybe about 11 arc minutes in size. There's a nice group of galaxies near it called the Deerlick group. And then about 40 arc minutes south and west of it is Stephan's Quintet.
And why did they call that the Deerlick group? I've never been able to figure that out.
Why is it
it's
the Wild
a strange
Duck Cluster?
name.
Why is it, yeah.
It was Antov Deerlick that named it.
Okay, we'll go with that.
Who knows?
All right, well, I'm going to move to Roy's view. Is that the Pac-Man?
That is Pac-Man. And I found out why it's so grainy. I forgot to turn my cooler on my camera on.
Ooh, don't you hate when that happens?
I looked at this and went, where are all those little specks coming from?
Well, it's right in the band of the Milky Way, is what it is.
Yeah. So that's why it was these images are so grainy. So I just turned it back on.
So again, an emission nebula, and also just talking about one of the advantages of stacking, that if you do forget to tune your cooler on and you can stack images, you can get rid of some of that noise that way. But the other thing is just cool that chip. The noise is typically thermal, meaning you've got the electrons and the ions in your chip are kind of vibrating around, and they produce this kind of spurious signal. So if you can cool them off, well, then they stop vibrating quite so much, and you can really lower the noise.
I usually cool mine down to about minus 20 Celsius.
So I just want to remind everybody who's watching this as well, and as well to the astronomers, like when this is done, feel free to upload all your images to the event where we originally posted that, and then everyone will get a nice email tomorrow who attended the event. If you're watching this, make sure you do click that yes, you attended the event, and that way you'll get that nice email. And then the other cool thing is that if you take astrophotos of your own and you want to sort of show the rest of the community, feel free to post a bunch of your images into the event, and then we'll see all your pictures as well. So it's sort of a nice way to sort of share all the images both from tonight's event and also just pictures that you've been taking this week or previous weeks to show off some examples. So feel free. Keep it to space, though, please. I've had to remove a few inappropriate images in the past. So, that's good. So, what is the Pac-Man? And I always joke about this, right? Like, what did they call it before there was Pac-Man? How did they?
NGC 281.
But they just, it looked like something. They just didn't know what it was, right? They're like, oh, it looks like something. It's the tip of my tongue.
Like Flying Wedge Nebula or something. Right? So,
yeah, the Valkyrie Nebula or something.
And Roy, are you also shooting H-alpha, or is this?
This is H-alpha, yeah.
Okay.
I had it in clear or luminance, and I had all the graininess, so I was like, well, forget it. I'll just go hydrogen alpha. Now I know why.
But again, if you look at the contents of the universe, of the stuff that we're made of, if you look at elements, not dark matter, we're not going to worry about dark matter. You can't see it, so we're not going to talk about it. But of hydrogen, helium, lithium, etc., 75% of all the atoms out there are hydrogen. So it's going to be the most common thing to find. It's going to be what's going to build stars for us. And so any place where it's condensed like this enough that it can be lit up by a bright hot star, you're looking at a region where stars are potentially forming, especially if there's like this dark finger kind of going into the middle here, the mouth of Pac-Man. That's a very rich possibility for star formation. You want gas and dust to be cool for it to be able to condense to form stars. So if it's glowing, well, that's not going to condense. It's already too hot. But if it's compressed and dark like that, then it's cool enough that, give it a little nudge from a supernova, and we're going to get some new stars out of that.
That's great. And it's got the little eyeball, too.
Mm-hmm.
It's perfect. Yeah, right up here. Yeah, that's great.
Pretty cool.
All right, so Stuart, you got another cluster.
Yes, this is Mercurian 6, and it's a curved line of about a dozen 10th magnitude stars, and it's only 0.1 degrees long. Runs north-south, and some people have described it as a lacrosse stick, and others like a fishhook.
Yeah, I can see the lacrosse stick. Now, it's always nice finding arrangements like this because it gives you some idea of how your camera is oriented if you're trying to figure out how to frame a shot. It's nice to have things where, okay, they're roughly oriented north-south. I want the north-south axis of the short side of my camera to be oriented north-south. Oh, good, I've got it. Right, this cluster lines up that way.
Oh, that's clever. Yeah, makes sense. That's great. Look at Gary's.
Wow, we got to show Andromeda.
Oh yeah,
that's fantastic. What a view of Andromeda today.
And I did it at 2x2 binning, so I've got some room to zoom in to some of the dark lane areas.
And look at those star clusters.
Yeah, dark lane areas and some really good, nice, bright star clusters. And remember, when we're looking at this isn't like the star cluster we were just seeing from Stuart that's right here in our own galaxy. Here you're looking 2.5 million light years away and able to see this collection of stars in another galaxy. And yeah, so Andromeda is just really, really rich with these.
Yeah, there's nice clusters there.
Yeah, look at all of them along there, those dark dust lanes too. Yep. This is one of the most kind of detailed Andromedas I think you've ever done, Gary. It's beautiful.
Well, yeah, and if I did it without binning and did a much longer exposure, I'd be able to go in even deeper. You did mention dark matter, Thad. You've heard the newest, that don't matter. It doesn't affect anything in the universe in any way. It doesn't matter. It doesn't matter.
Then there's no detectable signal, and there's no interaction with anything. Yeah, don't matter. Okay.
Doesn't matter, actually.
Or
doesn't matter. Yeah.
Doesn't matter.
Doesn't matter.
I think I can dilute that and take that as a homeopathic, solution then too, right? So,
Keith,
actually, I am right now.
To know how long's your exposure for Andromeda, Gary?
That is 2 minutes, and it's been 2x2.
So the binning essentially makes it something on the order of like what you would get with 8 minutes at 1x1. So there's 4 times as much light going into each pixel then.
Right. So if I had 4 times a time and I did it without or 8 times a time, I'd get this picture with more resolution. I wouldn't have the the tendency for the stars to turn square if you look at some of them here.
I think this would be another candidate for your HDR photography. Just give it a try and see about because that central core is just completely brightened out.
Yeah,
overexposed, right?
Yeah, totally overexposed at this point.
And I wonder what it would look like if it wasn't quite as exposed. Like, what can you see in that central core? Just a
shoot
bright...
me down some round to it, and I'll get going.
Some round to it, yeah.
Of course, you could go into Apple stores then and replace their hacked image of Andromeda with your image of Andromeda that actually has both dwarf galaxies in it. So if you notice off to the upper left in this picture, there's a little fuzzy thing, and then due right of the center of the galaxy is another little fuzzy thing. These are actually smaller galaxies that orbit the Andromeda galaxy. So our Milky Way has the large and small Magellanic Clouds. Andromeda has Messier 110 up in the upper left corner, and it has Messier 32 directly to the right of it in this image. Andromeda itself is M31. So 3 galaxies for the price of one in one field of view here. So.
And what you're saying that Apple actually removed those galaxies from their...
They took one of them out. I can't remember if it was M32 or M110, but yeah, and the images that they have as their default screensaver, they actually hacked it and like, oh, this looks like a defect in the picture. No, it's another galaxy. It's another couple 10 million, 100 million stars. Just leave it in there. So.
But if you're Apple, you get to do whatever you want.
Control the universe. That's playing God, isn't it?
So let's see.
I'm getting some background sound.
Stuart, are we on to another cluster here?
Yes, this is Stock 23. This is at the border of the, you're going to have to help me pronounce it, Camelopardalis? Camelopardalis?
So yeah, Camelopardalis. Yep.
Camelopardalis and Cassiopeia border. And it's identified on some star atlases, looks like Pasmino cluster, for John Pasmino of New York, who discovered it and described it in March 1978.
I like the little, it's like a little V.
Yeah, very distinct V shape on the upper, slightly left of center there, and then it looks kind of like, what would that be? It's almost kind of like a little staff or something.
I see like a little ray gun.
I think the
there we go.
That's the geese flying through the picture, isn't it?
Okay. There's just some very strangely distributed size geese. Right? Well, at least the big one's in the lead for cutting hair for the others. So that's good at least.
Yeah.
Good goose.
They're thousands of light years away. Very large geese.
But yeah, I mean, that's the one question I guess that comes with this. Then are these actual clusters where they are associated? Are they gravitationally bound, like when we look at the double cluster, or is it just happenstance that if we look in this direction of the sky, that these stars happen to line up that way? I don't know if there's been enough study done on these to know one way or the other. But then again,
it doesn't say in the magazine here.
Okay.
Right. So in some cases, they actually were, a cluster of stars that were born together and have been drifting apart. In other cases, they happen to be aligned in a way that looks like a cluster. But I mean, they have ways to detect, right? They look for similarities in age and metallicity of the stars.
Exactly. Yeah. If they have, roughly the same elemental makeup, the same percentage of nitrogen or neon or oxygen as in all the stars, that's one clue. Again, also looking at the age of the stars, if they all formed at about the same time, they should all be, roughly the same age, roughly the same phase of evolution here. So. Yeah. But again, this is fairly sparse. I mean, I'm seeing maybe about 25, 30 members to this cluster. So, how do you even get really good statistics if it's that few of a membership? The other thing it looks like to me, Stuart, it looks like you're resolving that the big goose at the front of the V, that looks like a double star. So it does. It looks like it's.
It does look like it's.
Looks like it's a double.
Yeah.
So.
So let's move on to Bill. Bill just posted an image. What have you got there, Bill?
It's two clusters, actually, fairly close to each other, NGC 1528 and NGC 1513, both open clusters. And they are in, I'm trying to remember where they're at. Let me look it up quickly.
But are they like the one cluster is obviously that one down on the bottom right, and then
bottom
the other
right and upper left? Bottom right and upper left, yeah.
Yeah.
And actually, if you look really, they're in Perseus. If you look really carefully, this is just very strange. I'm not sure what it is, or an airplane. I can enhance a little bit. You'll see kind of a red streak going just upper left to mid right. I don't know if you can see it on your view, but it almost looks like an airplane with a contrail that blew out in the wind or something. It's very odd. I've never seen anything quite like it. It almost looks like a meteor trail, but I don't think it is. Very odd. I've been having trouble with flat frames.
So I just got a message from Chris Ridgway. He's going to try and join us and bring us Jupiter. So that'll be great.
Oh, excellent.
Yeah. Yeah, unfortunately, we're not going to get Jupiter for the West Coasties until probably December, January. So we're still
It's up. It's right on the horizon, though. I mean, it is right on the horizon from LA. So I'm trying to think what my views will be like to the east next week. Because I mean, I will have wide open horizons in all directions if we have a virtual star party next week. So things like people have been requesting the Sculptor Galaxy NGC 253. If I can get a signal from out there, I should be able to bring it.
Oh, there you go. You've enhanced it. Yeah, no, I definitely see it.
Yeah, you see that weird? There's a streak that comes down across it. But then there are like fans coming off the streak. I'm not sure if that is it doesn't look like a meteor, but that's the sort of thing you'd see as a meteor trail dissipates. It's just pretty odd.
Yeah, I mean, we're not near the California nebula. I mean, that is in Perseus, but that's a good 15 degrees.
Yeah, it's quite a ways
south of there. So. It's a UFO.
Could you have any
the default explanation is? I don't think there are any. As far as I know, I'd have to look at my cloud sensor, but there didn't appear there were going to be any.
Yeah.
So Gary, we've moved to you now.
Okay.
I see this adorable little galaxy.
This was the 7331 requested.
Oh, nice.
Yep.
And my setup isn't real good for it, but here's this, and then this is the Stevens Quatraint. Is that it? Over in this corner.
Stephen's Quintet.
There we go.
So
now,
we've
can
handled the
you
request.
magnify and enhance the galaxy, or?
I can, a little bit. I had to do that at a 4x4, so we can't get much detail before it starts going square.
Yeah.
But there's a little bit of it right there.
Right. And you can even see, I mean, there's a few other little fuzzy patches near the galaxy. Those are parts of the Dirichlet group. So, galaxies come in groups of various sizes. If you have like the Milky Way, Andromeda, and the Triangulum galaxy that we talked about earlier, that's a group. So I mean, here we have NGC 7331 and a few other smaller galaxies nearby. This is considered a group. Stephen's Quintet, off to the other side of the frame, is another group, and actually one of the members of the quintet, it's a chance alignment that you have 4 of those galaxies that are actually near each other in space, and then there's another one, can't recall exactly which one, but there's another one in that group that just happens to be in the background by a few extra million light years and is shining through in the same region of the sky. So really, it's a quartet and then some guy kind of trailing behind.
Just a chance alignment.
His little brother.
Yeah, there we go. Come on, catch up. Yeah. So
that's great. Well, so there you go. So for the person who asked for 7331, we do take requests. We're not just marching to our own drum here. We've actually got we're happy to take some requests. But it's it's interesting about the setup. I mean, you really do, for those kinds of objects, it sort of switches to the big light buckets. I mean, you really want a very powerful telescope. More of an astronomical observatory type telescope to start
a long focal length. Yeah.
Or just longer exposures. I mean, binning 4x4 brings this out bright enough to be seen here in the virtual star party. But I know I've shot this with my 235 millimeter Edge HD, and was going with 8 minute exposures to really bring out any kind of detail. I'll see if I can dig up the photo I got of it to post to the Star Party afterwards.
But say that again though, a 235 millimeter.
Right.
That was a refractor.
That's a Schmidt-Cassegrain. It's a 9 1/4 inch scope.
Oh, okay,
So,
okay.
yeah.
But you had a bigger focal length than this one, right?
Actually, I was using Hyperstar, so I was shooting at focal ratio of 2.3. So I think Gary's using focal ratio 2.
Yeah,
so
2.
A little bit slower than that, but still, I mean, you really want a system that's that optically fast, that brings in a lot of light quickly, to get that kind of detail in a system like that. But you are trading off field of view. So I mean, something like this would benefit from being able to zoom in a little bit better. But then you wouldn't be able to get NGC 7331 and Stephan's quintet in the same field of view. So whenever you're doing observing or astrophotography, you really have to plan out, well, what do I want to do ahead of time? Okay, so I want, do I want to put on the Hyperstar? Do I want to just put the camera at where I would put the eyepiece? So there's always a lot of planning that goes into these sessions, and especially with the virtual Star Party here, that we've got a selection of telescopes from our 4 astronomers here that really kind of cover the range of huge field of view like Gary has here, to kind of a smaller field of view that Stuart can provide. So
yeah, if I shot that without any binning, we'd get a lot more detail, but I'd need to shoot at least an 8-minute shot.
Yeah.
So I've updated over to Stuart now, and that's great, Stuart. What a nice little cluster that is.
Thank you. This is M103, and I'm actually pretty happy with it because you can see different colors of stars in it, and that's one of the advantages of just having a straight shot DSLR, is that you can get this color right away, as opposed to having to do RGB different shots, and it's a little more immediate gratification.
Well, and I think it's really important for these star clusters. Like, I find you really want that color view to see the texture. I mean, otherwise it's just a smattering of dots. But once you get those colors in there, then you can really see those different textures of the stars. It's great. Beautiful picture.
Thanks. Speaking of which, I just found the blue snowball, and I think I got a reasonably good picture of it. So
okay.
We've never seen that before. Let me pull it up here in a sec. Go on to somebody else. I'll be back, and I'll be there in a sec.
Okay, sure. What did you say was M101? Is that right?
I'll have one in a minute here.
This was M103 that Stuart had. So
I think Roy had something. Roy, what have you got here?
Actually, what I brought up was it's the object that Gary was showing, but in 2 different fields of view. You can see the box around it. So
cool.
The inner one would have been my 8-inch. That would have been the field of view for my 8-inch, and the outer one is for my 106 millimeter, which is probably about what Gary's field of view is.
Yeah, it looks pretty close.
Mm-hmm.
With his Hyperstar on his scope, we're about the same. But if I was to use my 8-inch, I'd get the inner one.
Right. Oh, there it is. There's the blue snowball. Look at that. Wow.
Yeah, it's blue.
It's blue.
Very apt description.
Yeah, and if you look right on the edge of it, I don't know if you can see it in the VSP view, but you can see how it's just a little pixelated right on the edge of it, because it's so small that you can just see little squares of the pixels around it. But it's blue and it's cool, and I've never imaged it before.
So this is a planetary. Yep.
Yeah.
So just like the ring or the dumbbell, but what we're really getting strongly here is ionized oxygen. So really strange. There's none of the typical hydrogen coming through. That gas is probably blown away pretty well by now, and so just oxygen being lit up somewhere in that blue snowball is a white dwarf star left over from when the star that used to be this planetary nebula died, and it's going to be pumping that oxygen full of ultraviolet radiation and getting it to glow with this really gorgeous blue color. So if we were looking at this, like say with Gary's setup, it would be one single dot. But Stuart's view here gives us a much smaller field of view of the sky, much better for something like a planetary nebula like this.
Well, and we've just been joined by Chris Ridgway. Hey, Chris.
Hello.
Hi, Chris.
I can see. Have you got some clouds there, or are you just messing with your focus still?
I'm messing with my focus, and I just had a small puff of cloud that's come over here, but it's moving out. and we'll have it real good here.
All right. Well, just let me know when you're ready to go, and we'll take a look at it. That's a phenomenal object, Stuart. I think this is becoming my new favorite. That's wonderful.
Oh, thanks. I remember when I first saw it with my old mount and my old telescope. I found it with my Dobsonian just by doing star hopping, and I was so excited I was jumping up and down. I mean, it is so hard to find.
That's tremendous. Wow. Okay. Well, I'm going to move back to Bill. I mean, there's a whole bunch of objects coming up now, so we'll move quickly. Oh, Bill, that's beautiful. Wow.
That's NGC 1502, which is in Camelopardalis, if I say that correctly. It's one of those ones that twists your tongue. It's about 2,700 light years open cluster.
Okay. So these would be definitely associated with each other. Anytime something is known to be an open cluster, we know that these stars formed at about the same time. And if you look, they all have roughly the same color, meaning they're about the same spectral type. There's definitely at least one bigger one toward the center there. And then again, as we look away from the center, we see some of these red stars. There's an especially red one off to the very left of the edge of the field of view there. So
same thing then. These are probably mostly red giants.
Any of the red stars here, yeah, they would definitely be. Unless I can look it up and see that there's a nearby star in this region of the sky. If you're seeing red stars, they're going to be red giants. Yeah.
Wow. Phenomenal. Okay. All right. Well, I'm going to move on to Gary's view. It looks like the pinwheel. No.
This one's a test
propeller.
for you. Yeah.
This is the propeller.
See if you could pick this one out, Fraser. It's the propeller.
I gave it away. Sorry. Yeah. Sorry, Gary.
And that's a.
I'm ready for Thor's helmet, though. When Thor's helmet comes back on, I'll be ready.
Yeah.
So, yeah, again, with hydrogen alpha showing, here's the primary element of the universe again, and just really interesting the shape. You kind of wonder what the process was that caused this to happen. That if it's just we're looking at it a certain way, so it has this kind of twisted propeller shape. Is there something that was spewing gas out in two directions, and as it spun, gave it this shape? So there's a question of how did it get this form that we're looking at here. I mean, with a spiral galaxy, we know there's these density waves in it, and as those density waves progress through the spiral galaxy, it gives it its spiral structure. Well, this isn't something that's, nebulae typically aren't organized as much as like a spiral galaxy, so it's kind of curious to say, well, okay, why does it look this way?
That's really neat. Okay, let's take a look at this view of Jupiter now. It's been coming and going. I've been watching it. I think he's got some clouds happening. Yeah. He's battling a puff of clouds here. All right, well, we'll keep an eye on it. Come on, Jupiter.
So looks like Roy's got the elephant trunk in there, though.
Yes.
All right, we'll move to Roy's view. Oh, beautiful.
Yeah.
I love that. Your setup is just perfect for this. Is this why you bring it up every week? Your setup is just fantastic for this.
This is one object that actually shows up really good in my setup.
So, yep, you do what you're suited for, and yeah, definitely this Roy setup is really well suited for this one. So again, what we're seeing is dark, cold molecular gas dust that's kind of blocking the view, and there's an outline where it's glowing more brightly, kind of giving kind of the edge of the trunk shape there. But just these little wispy curlicues going off into space from.
Okay, I'm moving to Jupiter right now.
Go! Get it!
That's perfect. Look at that.
Awesome.
Oh wow, Chris, that is phenomenal view of Jupiter when it settles down.
Yeah, still a little choppy in the atmosphere, but finally brought it out.
Is that the red spot right in the middle there?
Looks like it.
Yeah. And okay, so no, those are bits of dust. I was going to say those might be transparent.
There are specks of dust all over the camera. It's hard to clean these computer webcams.
Yeah. So I mean, we've got a nice festoon. It looks like off of. I've seen most of the festoons coming off the north equatorial belt. So north would be to the lower right in this view, if I'm seeing this correctly. Let's see. I'm kind of asking because I haven't done quite as much shooting of Jupiter.
Yeah, I see a moon.
Oh, we got a moon.
Oh, nice.
Yes. Oh, which one is this? All right.
Someone said that's Europa. I'm gonna check and see.
I was gonna say, let me check my my phone app here, and it'll tell us. I'll know for sure if that's the red spot. No, that's actually Moon.
Yeah, it is Europa.
Very good. All these worlds are yours to explore.
Except for that one.
Stop looking at it. So, but yeah, I mean, every once in a while we get the atmosphere settling down for Chris really well here, and you can get a chance to see some of all these incredible swirls. I mean, Jupiter, from one side to the other, if you were to go across one of those belts, you could stack 11 Earths, one right next to another, again along those long belts on there. The thing is, though, Jupiter spins once every 10 hours or less. It's about 9 hours, 50 minutes at the equator and a little over 10 hours at the poles. It's not a solid body, so it can spin at different rates like that. And I mean, this really, if you thought Sandy was a superstorm, you don't want to see anything on Jupiter.
Did you see that? There was like a meme going on the internet. Someone was like, a picture of Jupiter beside the Earth, and it's like, tell me all about this storm you had.
Yeah.
About your superstorm, yeah.
So, but yeah, has anybody been able to confirm that North is at the lower left corner here?
Yes, I did, and that is not the red spot either. So yes, you're correct. It's flipped, and
yeah. Well, the red spot, no, but the red spot is there. So
I'm not sure it is.
It's not showing up at all on my.
It's showing up on my. Whoops. Yeah. Hold on.
It would be on the south equatorial belt, which is toward the top right in this field of view, if it is there. And I mean, this is the thing. The red spot. Go ahead.
Hold on. Sorry. So we see where Europa was. That was on the. Man, I'm not sure if that's.
That was on the left.
South. Yeah.
So
it's on.
Like I said,
it's on the same kind of altitude, the same latitude, but on the other side of the planet from where Europa was. And so that's not that object that's right in the middle is not the red spot. That's like a sort of a bluey storm in it. But the red spot is going to be sort of opposite from where Europa is. So if you just follow a line from Europa into Jupiter and keep going to the other side, that's the great red spot, like right over on the side.
On the opposite side there. Okay.
Yeah. Okay. At least that's what Stellarium is telling me, and who knows how accurate it is for the rotation of Jupiter.
Yeah. Again, I would trust either. Well, it's called wind. JUPOS, so I guess WinJupos. Yeah, WinJupos. I mean, that's by far the most accurate thing I've seen for tracking positions of moons and storms and whatnot. But Skyview Cafe also does a really good job of showing the correct timing for moons and their shadows, transits, eclipses, as well as the position of the red spot. I think he's got. I'm not sure if Stellarium programs in that. From one side of Earth's orbit to the other, there's a 16-minute difference of when these events happen. And so if Stellarium doesn't take that into account, I mean, it could show that things are there that have actually rotated off, or that things aren't there that have actually rotated onto the field of view of the disk. I know Skyview Cafe and definitely WinJupos will take those things into account.
Yeah,
Stacy Ridgway is very proud of this.
Sky Safari is showing that the red spot transited about 3 hours ago.
So it'd be gone.
Time.
Yeah.
So, yeah, it's already gone.
Oh, okay. All right.
I was going to say, I mean, it can be tricky to see, but with this good of an image, it should be visible if it is there. So, I mean, if we're seeing all these little festoons and bars off of well, from our point of view, it's to the top of the, more toward the center of Jupiter from the north equatorial belt being down and to the left in this image. But we're seeing all these festoons, we're seeing bars. When the atmosphere settles down, you can really see some of this incredible structure in Jupiter's atmosphere. So if you can see that, the red spot would definitely jump out at us if it was visible. So.
What a phenomenal view of Jupiter. That's just fantastic, Chris.
Yeah.
Great. I'm really glad that the atmosphere settled down for you.
Thought I'd try to come through for you.
I know, it's great. It was you said, is anyone gonna give us Jupiter tonight? And I got back to you and said, no. You're like, okay, I'll do it. So that's great. What a view. Wonderful.
All right.
It's so great to have Jupiter back. It'd be nice when we get Saturn back. I wonder when we're gonna start getting Saturn back in the evening again.
Well, Saturn just reached conjunction last week. Saturn was in conjunction with the Sun, so they are diametrically opposite each other in the sky right now. So, if Jupiter's up, essentially Saturn is not at this point.
Yeah.
So I guess as we start to lose Jupiter is when we'll start to get Saturn back.
Probably not March, April, I guess.
Yeah, I think it reaches opposition at the end of April, beginning of May.
Yeah. All right. Well, let's do a quick roundup then of some of the other stuff, and then we'll head out on Jupiter. So I'm going to move back to Gary's view here, and then we'll. Whoa!
Yeah, this is rich.
This is Gamma Sig in Cygnus.
Yep.
And this star, this blown out star right here, is it Sadr? SADR?
Yep, that's it. So.
Yeah.
So this is the heart of Cygnus the Swan, or the center of the Northern Cross, and again, you're looking along the thick of the Milky Way. You pick up all of this extra hydrogen. Is that? I'm trying to get oriented here. I mean, I should know this region really well. Is that M29 off to the side, or is that? I mean, the thing is, there's something like 15 different star clusters in this region of the sky.
Yeah.
So.
M29 is out of my field of view. Why is it doing this?
But there's a cluster down at the bottom, like right of this image, right? Yeah.
Yes.
Right
So,
here.
if you
don't show it.
The thing is, I know, like looking at the Uranometria 2000, I picked this region of the sky for my summer project this past year because there's so much going on here, and I know there were listed all of the hydrogen that you're seeing here, about 15 star clusters, including M29. The Crescent Nebula is not very far from where we're looking here either, so it's all right in this region of the sky. So just gorgeous region.
Down
of the
in
sky.
here is Herschel H56-8. It's either this cluster or over here.
Yeah. It's something where you'd really need to take a shot and then go look at it separately and then start your identification. Okay, this is this and this is this and this is this, because there's just so much going on in this picture. So that's terrific.
How narrow are your hydrogen alpha filter, Gary?
12 nanometer.
Okay.
Well, I'm going to do a quick roundup here, and then Bill, you've got another object for us here.
Well, this is I picked probably the toughest object you could find. This is really not intended to be done in a few minutes, but this is Vandenberg 152. Actually, I think it was an APOD on Halloween. Obviously, a much longer and better image of it than that. But you can kind of see the trailing off from the left or toward the left. You can kind of see the reddish. Now, this is a red filter that it was taken through. Very difficult to pick up. I do have another image that I'll switch to now because it's actually an object I'm working on at the moment to get a better image of it. So I'll bring that one up, and it's flipped upside down in that image, but you can see it much better, clearer.
When you're finished with it, could you post it to the event so people can?
Yeah, I can do that. I think I've probably got enough frames. I just haven't had enough time to process it.
Right.
But my friend actually calls it the Star Destroyer Nebula because he thinks it looks like that episode of Star Trek where they had that big cornucopia thing that used to eat planets.
Oh, right.
Okay.
Yep.
From Star Trek, yeah, I remember that.
Yeah, from Star Trek.
Okay, I'm going to move to Stuart's image. What is that, Stuart? Like a little galaxy.
Yeah, that's the same galaxy that was requested earlier this evening. NGC 7 something or other, 7331 I think it was. Yep. And I didn't see Gary's, but I just wanted to do a comparison of the field of view. You can see how small it is. I did not crop this at all. And so it's a tiny little thing.
Yeah.
And just 1 second, I'll have M13 just to kind of go out on here.
Sure, and I was hoping to go back to Chris, but he's got the clouds again. He had a beautiful, crisp view of Jupiter for a second there, and then clouds again.
Give me 1 second, Fraser. I'll bring it right back up. I don't have clouds. I just switched to try to make it look better.
It looked better.
Yeah, I'll have it just 1 second here.
Yeah, with Stuart's image here, you can see a few of the little fuzzy patches. It looks like a little bit below and to the right of NGC 7331. So, I mean, that's some of these other galaxies part of this deer-lick group. And it's actually 3 words, deer-lick group. Like there's like a deer tongue or something. It's slurped up the galaxy. I don't know what the heck they were thinking. So,
but we can't see the Stephan's quintet in this one.
No, I mean it should be in the field of view, but it's a pretty faint object.
Yeah.
So you really need one of the bigger scopes like Gary has to bring it out well. So, but again, every scope has its advantages for particular objects. With the blue snowball, I mean that was terrific. So.
Yeah. And Roy, have you got something coming here, or is that?
Yes, it's downloading over my cellular connection.
Right. Well, people, yeah, you're operating out of your home in Vegas, and then you're accessing your telescope in Arizona. So
yeah.
There we go. Oh, nice.
I'll let you guess what that is.
The bubble.
Yes, it is.
Yep.
Oh, it's beautiful. And there's like a star cluster in this too.
Yeah, in the upper left.
Yeah.
So you guys have imaged this so much, I think next weekend I'm going to have to get a shot of this. So it's like I need it for my collection. So
well, why don't we? Well, that was fantastic. Why don't we? Oh, Gary's got his previous one. Okay, so why don't we?
I brought it up so Stuart could compare.
Oh, yeah. Right, and Stuart had one more star cluster for us.
M13, the Hercules cluster.
Oh, that's nice. Oh, that's beautiful.
Oh, that's good.
Mm-hmm.
Yeah.
Yeah. Yeah,
you
good.
can really see the stars there.
A nice arc of stars off the bottom of the cluster there. A little kind of arm, it looks like. So.
I always have a problem shooting globular clusters. They just never come out well.
Because you pronounce them wrong. They're globular.
Oh, it's globular. Yeah.
They're offended, so they won't focus for you.
And we'll just leave on. We'll close tonight with this beautiful view of Jupiter that we're seeing right now from Chris.
Yeah.
So thanks a lot, Chris. So thank you very much to Bill, and thanks to Chris, and thanks to Gary, and to Roy, and to Stuart, and thanks to Thad for bringing the knowledge. It was fantastic to have you all join us. Great night. Wow, beautiful view of Jupiter. I'm really, really pleased. That was just wonderful. So thanks, and thanks to everybody who watched, and we'll see you all next week right here on Google+.
Thanks, everybody. Good night.
Bye, everybody.
Thanks much.
Have a good night, everyone.